How does HSRP determine which router in the group will be the active forwarder? Because remember, one active forwarder, one standby router, and then all the other routers are just waiting. So only one router can be forwarding for that particular HSRP group. Well, it starts off by examining the priority. So every single router within that HSRP group has a priority. And by default, that priority is 100. So as the hello packets go back and forth, the priority is included within that hello packet. So all the routers can examine who has the higher priority. Well, if the priority is 100 by default and you don't manually change it, then we have a tie. So if there's a tie, the router with the highest configured IP address becomes the active forwarder. When we examine this configuration here, which of these multi-layer switches, DSW1 or DSW2, based on priority, then the higher IP address becomes the active forwarder in this case. Well, when I examine this topology, I see that DSW1 has an IP address on their interface of 10.1.10.2. DSW2 has an IP address on the interface of 10.1.10.3. So this is the interface on the local area network where the hello packets are being sent and received. So it'd be these interfaces right here we're talking about, right here. As the hello packet goes back and forth between these two multi-layer switches. So based on that, if priority is tied because we haven't changed it, then I am going with the fact that this multi-layer switch, DSW2, becomes the active forwarder because we have priority tied in this case. It's defaulted to 100, and then when a tie occurs, the router with the highest IP address becomes active. So DSW2 is active in that particular case. But what about our live topology? When I analyze DSW1, it says it is the active router, the active forwarder. So if we look at do show run interface VLAN 10, we see that this interface has an IP address of 10.1.1.1, and it is part of that standby group. If you go to DSW2 and type in the same command, do show run interface VLAN 10, we see that it has a configured IP address of 10.1.1.2. Wait a second. Based on the syslog messages, it says DSW2 standby, DSW1 is active. But we just analyzed that the election process is based on priority, which is tied because we haven't changed it here, and then it's the higher IP address that wins. We have 10.1.1.1 on DSW1. We have 10.1.1.2 on DSW2. 10.1.1.2 is higher. I don't even need to take off my shoes to figure that out. So 10.1.1.2 is higher, yet DSW2 is still standby. So that election process isn't entirely accurate as it has been described to us. Because DSW1 should be standby while DSW2 is active based on this process that we've seen. So what is happening here? Well, when HSRP devices have HSRP enabled on an interface, it's really a race to get to the active and standby state. We can see here that the first state the router is in is the initial state. And the initial state happens when the interface first comes up. So the device knows that HSRP is configured, the interface comes up. So let's say the interface is shut down, or you just plug the cable into the interface and HSRP is configured, you are in the initial state. And then after that, you move to the listen state. So when you are in the listen state, you know the virtual IP address because you've been configured with it, and you are listening for hello messages from other routers. So the goal in the listen state is to find out if there is currently an active forwarder or a standby on that particular local area network in that subnet. If you don't hear from any other device, so you're not receiving hello packets stating that there's already a standby router or an active router, you move to the speak state. And in the speak state, you are now actively trying to participate in the election process. You're trying to figure out if you can become active or standby, because neither of those two roles, or maybe only the active role, exists. So you're trying to become standby. So you're participating in the election process by sending hello messages now. This happens in the speak state. And if for some reason there is no standby router currently, or no active router, well, then you'll promote yourself to active. However, if there's already an active router, then you'll promote yourself to standby. Notice what's happening here during this race. Router A was started much earlier, or configured for HSRP on the interface much earlier than Router B. So when initial, listening, speak, realized there was nobody else out there, promotes itself to active. And when Router B was initialized, as we can see here, there was already a device that was active. So it's listening, it hears that there's already an active device, but doesn't hear a standby device. So then it starts speaking itself and sending out hellos to determine if it can become the standby router, which it does. So even though Router B has the higher IP address, it doesn't become the active router, because this race to the active state overrides that process of highest priority followed by the tie by default. Now, why is that? And that is what has happened in this environment. Because HSRP was enabled first on DSW1, it got to the active state before DSW2 even had a chance to start sending hello packets. That's why DSW1 ended up in the active state. So the router with the highest priority should be the active router. If it's tied, it should be the router with the highest configured IP address. But if some other router starts first and gets to the active state first, it wins. It will be the active router. And by default, another router, regardless of higher priority, cannot take over that active role, because by default, preemption is disabled. Preemption is disabled. Preemption is an option that states, if I have the higher priority, I am taking over that active role. I don't care if you're currently the active device. I have the higher priority. I'm taking over. So if you want to force who the active device is, you can change the priority, make it higher, but the only way that device will take over is if you also enable the preemption process, which takes over that active role from the current active device.